Hello, hello, hello. Yeah, I can hear you perfectly. You can just check that if you can hear my voice from the device. Hello, hello. Any update or coding? Yeah, it's you can hear me from the live stream, right? Okay. So just drop the live stream link in my DM once. I will post it after the session starts. Okay, let's wait for some few minutes. Now we can start. 8 actually. we can't hear you, Kunal. Just do one thing, rejoin the voice chat again. Maybe some issue with your network. You can just leave the stage once and then again join. Maybe some issue is with your network or headphone or anything. I don't mention. Argotik, you can hear me? Argotik, hello. Am I audible? Yeah, okay. Yeah, Kunal.
Hello, hello, can you hear me?
Yeah, we can hear. Yeah, we can
Okay,
start.
okay. Should we start?
Yeah, we can start actually.
Okay. So, good evening, ladies and gentlemen. I am Kunal Das, the official host of the Resourcio community, and welcome to our first session being conducted on Docker and containerization, hosted by the very own Irshit Mukherjee. And this is our first step into rebuilding or restructuring our community. So I hope all of you will pay attention to the session as it's a very innovative and interactive session. I hope you all learn a thing or two from this interactive session. Also, another thing, during the middle of the session, Google form will be created. In that form you can fill up, and basically the form is curated for queries. Like have any queries, you can just fill up the form, and those will be addressed later on in Meet. And also, like the form, the people who fill up the form and stay towards the end, like only they will be receiving the certificates. So please try and stay till the very end of the Meet. Now, without further ado, I would like to request our host or the person who is taking the session, Irshita, to please step up. So everyone, please welcome Irshit Mukherjee. Thank you.
Hello, hello. I hope you guys are doing fine. Good evening. So I can start right now. So am I audible? Hello, guys. Hello.
Yeah, you are. You are.
Okay, okay, okay. Okay, I won't be able to share the screen. Can you give me the access of that?
Yeah, just checking. Aratrik, are you there? Hello, Aratrik.
Yeah, yeah.
Yeah, can you just check the screen permission because I am not able to share the screen also.
Mm.
Yeah, me too, me too. I'm not even able to share
Ishita
my
can't
screen.
share the screen, right? Just wait a minute.
Yeah.
Yep, yep,
Also,
yep.
I can't also share the screen. Just checking the feature now. Maybe some permission issue. Yeah. Check.
Okay, just wait for 2 minutes.
Yeah, yeah, sure, sure. Okay, guys. So this will be an interactive session. You have to interact with me. Okay. So don't make it boring. And I will also try my best to not bore you. Let's start. First, let me check if I am given the access or not. It will take some time.
Yeah. some issue with the permission rights.
Do I need to leave and again join the meeting, or I can stay?
No, no, you can stay. We are facing some other problems.
Okay, okay, sure, sure.
Is it happening for the number of people joined in the stage? Because I have checked previously, uh, then it was happening when there are 10 or 15 members. I don't know why this happened.
Actually, the thing is, there cannot be more than 50 members in audience or screen sharing without.
Got it, got it. Okay, we have to restrict member count to 50, right? Three.
Yes.
So, yeah.
I didn't get you.
So, should we reduce the member count to
Uh,
50 here? Should we reduce the.
uh, just wait
Because
a
we are
minute.
doing a
Let me
live
just
stream
check.
also in the YouTube, so can also they can also see the session from the YouTube stream.
Mm, just make it up 45 members then.
Okay.
And share the YouTube link with the general discussion so everyone can listen to that YouTube
Just
live stream.
make it 45 members in the audience, and yes, we can do it.
Yeah, yeah. I have reduced the number of members.
If
And
anyone
don't
else,
worry, guys.
if anyone is here from core team, you guys can leave and join later. Just let audience be part of the session for now. Now you can share,
Yeah,
Irshit.
yeah, now I can now I share. Okay. Even if you cannot see this here on Discord, so you can actually join this YouTube session. And also, I would like to tell you, you don't have to be worried about anything. You will be given a YouTube Google form there. You can be share your doubts and all, and I will be able to uh, solve this out. Okay. So you don't need to worry about anything. You can tell all of your friends, those who have left. So I will start screen sharing. Is it visible? Hello.
Yeah, it is visible.
Okay. 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 So first, I would like to start with my introduction. Who am I? So first, I would like to tell you that I am a backend and DevOps developer at Xconix, and also I run a YouTube channel. If you want to, you can go to my YouTube channel. You can see the all of the videos that I have posted. I love to share my documenting. I love to share my learning in YouTube, so you can check it out. This is the channel link. You can go and check it out. And also, I would like to tell you about Flint. I am creating a Flint on my side project. I am going to release it on product hunt. If you are excited about this, you can check this all of this URL of these are the two people who helping me out, Yogi and Vishak, Nirakshi and Vishak, who is helping me out on this project. So these are the links, and let's start with our today's session about Docker and containerization. Okay. So first thing I would like to tell you about is what are the people who needs to learn Docker containerization. So it is irrespective of any field that you are interested in. If you are a front end developer, if you are a back end developer, if you are a DevOps developer, you have to learn Docker. Okay, it is irrespective of any field. Okay, so what is a Docker? What is containerization? Before going into Docker, you have to learn what is containerization. Okay, so and containerization is a technique. It is used to isolate environment for the application and the dependencies. Okay, and you may have heard the problem. It was on my machine. Let's suppose you are building a product and you have deployed it on your and you are running it on your Windows machine. Okay, and let's suppose you are working with your coworkers and your coworkers have Linux and Mac OS. They might be having multiple different OSs, right? So now you are giving that application to your friends and your app may break while working. Okay, right. Why this is happening to you? This is happening because of your application is tightly coupled with your system or your OS, right? When you are building something on your when on your OS, it becomes dependent on the OS, right? So it can occur on production like the things that are running on Windows, it might break on Linux. So these are the problems solved by containers. Okay, container uses the techniques named as C groups and namespaces. I'm not going into the depths of what are all of this. These are complex topics, but these are the techniques that will help you with the isolation and all of these things. And also there are other problems. Like let's suppose you have Java application, right? And you are using Java 8 and you have a code that is a legacy code which is using Java 6. So there is a dependency issue, right? So you need a standardized way, you need a standardized environment where you can run the both of the versions in a single host, So how you will be able to do that? Yes, there are package managers and there are version managers, but but at the time of deploying, it will really break, right? Because at the time of development or at the time of production, anything can occur. So you need to be very cautious about all of these things. All of these things can be fixed with Docker. So you can see that containerization is a technique which is actually which is actually isolates your application with all of the other things. So it may look similar to the virtual machines, right? But there are differences between containers and virtual machines. Okay, so you can see in this picture, if you take a closer look at the containers, you can see that in the same host operating system, you are able to run this container, right? But at the time of virtual machines, you have a hypervisors and you can run multiple OS. So what does multiple OS means? Multiple OS means your multiple OS will consume more memory, more RAM, more CPU, right? So this is resource intensive. Okay, virtual machines are resource intensive, but at the production, you need to take care of all of these things, right? You cannot take too much memory, too much space. You need to run all of these applications in a very lightweight environment. So how will you able to do that? You containers will give you that power, so you can run your applications in a very lightweight environment, and your application will be isolated from each other. Okay. So at the time of virtual machines, there is a thing called hypervisor. What does hypervisor do? Hypervisor is actually separating all of your resources one from another, so you can run multiple OSs in your same infrastructure. Okay, so those who have used virtual machines previously, they knew that before downloading an OS, like you are using a Windows. Okay, you have downloaded a virtual machine and now you want to add a Linux. So what you have to do first? First you have to separate the resources, right? First you have to partition your hard disk space, and then you can download the OS on the specific on the specific part, and then you can download and run this OS inside this, and you can run the application inside that virtual machine. Okay, so this is about virtual machines, and at the time of containers, it is not separating the operating systems. Okay, you can see that on this image, we are using the same host operating system. We are not actually using multiple operating system. We are actually using a same operating system, but our container engine is actually isolating all of these application one from another. So I have to tell you why we are doing this. Let's suppose you have a Postgres database application and a backend application. It can your there can be scenarios where your Postgres application can break the backend application because the network is actually breaking each other. Okay, so you need that isolation, right? So this isolation will be done by container. So in one container you will be running your backend, and in one container you will be running your database application. Okay, so this is about containers and virtual machines. If you have any doubt about containers and virtual machines, you can ask right now. Uh, they can write. Shomajit, hello, hello.
Can you repeat once?
If they have any doubt, how will they will to will or
They
write
can
it
just
out?
come up as a they can write the thing in the chat box.
Okay, okay, okay. If you have any doubt, you can write on chat box. So how will I able to see that?
See in the stage at the top right corner you can find a chat box, and there we are already talking. Wait, I'm pinging you once.
Yeah, yeah, sure,
Uh,
sure.
See, I have already pinged.
Okay, so you can write your queries right now. If you have anything related to that containers versus virtual machines, if you have any doubt, you can post it there. For website, is it application applicable? Yes, it is application. It is applicable for websites also. If you have a front end application, it is at the end of the day, it is a normal application, right? Let's suppose you are running a React application. So you can run that React application on a container, and then you can host it to the internet. Okay. So this is the first, and other are how Docker containers are different from VirtualBox, where we install OS in primary OS virtually. Okay, so this is the difference. I have already told you that hypervisor. What is hypervisor is doing in virtual machines? Hypervisor is actually separating all of these OSs, right? What hypervisor does? Hypervisor is separating the network, the CPU, the RAM. All of this thing is separated by hypervisor, and they can run your application on a separate machine. And at the time of containers, container is not separating your operating system. It is running inside the same operating system. Okay. In this picture, you can see that this is a virtual machine. This is the architecture of virtual machine, and on inside this hypervisor is running multiple OS, right? So one OS can be Windows, second OS can be Linux, and third OS can be your any like Ubuntu or other can be CentOS, anything. It can be anything. Like it can be also my Mac OS. It can be anything. And at the time of containers, you can run your Ubuntu or images inside this container. Okay. what is implementation of Docker for Android development? It's also same. It is not actually tied with Android development or web development or cloud. It is not tied with anything. Okay, it is just a way to package and build your application. Okay, you may have used your at the time of development. You may have used multiple types of build tools like Maven or anything or npm, right? It is kind of like that. It is what it does. It is actually packaging and standardizing your application in a way so you can run each of your application in isolated level. Okay. How is it applicable to Java? I have seen the same program running in a computer but giving error in another. While using BlueJ, how it will work? Uh, how it is applicable to Java? I have seen the same program. But giving. Okay, so this problem can be solved using container. Okay, so right now you are having problem with same like a same program is running on your computer, but it's giving on the other, right? So you for what you have to do, you have to make your Java application into a container, and then you can run the same container in a other application. Okay, is it like using a parallel space at a same system? Yes, you can see you can also think of it like that. Like it's a way of using your resources. Okay, it's actually way how you can how you can utilize your resources. It is actually logically separates your CPU and RAMs. Okay, which is an abstraction. So you are not able to see that, but what Docker does, what Docker is actually thinking in a way. So let's suppose your Java application needs more memory and your JavaScript application needs less memory, right? So your Docker engine is actually Docker container is actually thinking in a way and separating the resources as per their need. Okay, and how do you handle security concern in Docker, particularly regarding container isolation? Okay, so this is a very good question. At the time of virtual machines are very secure. Okay, but there are also a thing called if you cannot get all of the things inside one thing, right? So the con of using containers is that Docker containers are less secure. Okay, so if you need more security, then you have to use virtual machines, and but containers are vulnerable to the internet. But there are multiple ways how you can secure your application. You need other tools for the security. There are multiple ways you can leverage the security inside your Docker container. I know you guys have lots of queries and doubts. Just bear with this session. You all of your doubts will be covered. Okay. So I am just moving into the next slides. I will be reaching to your doubts after this. So let's go to the next slide. So what is a Docker? I have told you what is containerization is, right? So Docker is a tool or a platform that is helping you out with creating, building, and managing your containers. Okay, and what your Docker is doing, Docker is helping you out with this all of these four things. Lightweight. So containers are lightweight. I have already told you why it is lightweight. Because it is not separating by multiple operating system. It is using the same operating system. Okay, it is using the same operating system, and your Docker engine separates the resource one from another by leveraging the power of C groups and namespaces. They are doing it, so that's why they are lightweight. And for portability, you can see that Docker containers are very portable. You can create your there is a thing called Docker image. I will tell you what is a Docker image is, but you can share your Docker image with multiple people. So it is very portable and efficient. Or you can see that you don't have to run multiple operating system on this host operating system. You can run multiple applications in a virtual environment. And isolation, I have told you also what is isolation is. So in your Docker, every container is isolated from each other. I have already told you, like your node application. If you are deploying your node application in a container and you are deploying your database into a container, those both of the things will be isolated from each other. They won't be affecting each other. Okay, so this is these are the all four things that are the pros of Docker using Docker. And what is Docker? Docker is at the platform which is helping you out with all of these things. There are multiple types of containerization tools and techniques. Docker is one way of doing that. Okay, I guess it is clear. So, what is the difference between Docker and containers? Containers, containers help you with containerization. I have told you what is the difference between virtual machines and containerization. And Docker is a tool that will help you to get that power of containerization. There are multiple other tools as well as they also exist to leverage the power of containerization. Also, I would like to take a quiz right now. Anyone, can you tell me, can you name another tool other than Docker? Do you have any idea? Can you tell me other tools that can also act as an containerization tool? Kubernetes, actually, it is not. Kubernetes is actually not help you. Kubernetes is actually help you out with uh, your container orchestrations. Let's suppose you have a container and you have to manage it, right? So what it does, Kubernetes actually manages your containers. It is not a way of doing the containerization. Okay, so it is not actually a perfect answer. Okay, so a Podman is the correct answer. Linux container LXS right answer. So Somaji, are you writing the names?
Yeah, I'm
Listing
right.
down all of these names. So,
Yeah.
so the first right answer is the Podman, Victor Hill. Good job. And second is yes, Bilda is right. Ankit is also right. Shubhodjyoti is right. Nice, nice. Great, guys, great. Actually, Minikube and Kubernetes is not a containerization tool. Okay, it is actually container orchestration. Okay, and Minikube is a platform with where you can leverage the power of Kubernetes. Okay, it is it is a container orchestration tool. Okay, so I'm moving to the next slide. So I have already told you what are the benefits of Docker. It is helping you out with consistent environments. Okay, so you can run multiple environments, multiple containers at the same time. It will be very consistent. They won't be affecting each other. And simplified deployment. This is the beauty of Docker. Okay, you can deploy Docker anywhere. Like if you have an EC2 instance in AWS, if you have anywhere, if you want to deploy it, uh, it will make your deployment process very simplified. Okay, and also it will help you out with the collaboration. I have already told you how Docker helps you out with how you can leverage the things like Docker images and containers. So you can share all of your images with your coworkers and your teammates. So that's how you can collaborate using Docker. Okay. There is a thing named as Docker Hub. Okay, Docker Hub is a Docker container registry where you can publish your own containers so other people can use it. You can also make private repositories. You can make public repositories. It is same as GitHub. You can think of it like as in for the containerization, GitHub is actually Docker Hub. Okay, there are multiple registries other than Docker Hub like ECR. Google also has a container registry. Azure has it. So there are multiple types of registries. There are private registries and public registries. So what is private registry? Private registry is like private repository. If you are working on a company, let's say you are working on a company named ABC. So you will be creating your private repository named as ABC, and then you will be uh, push your container to that ABC repository. So only that participants who are inside ABC organization, they will be able to um, uh, pull that image. Okay. Now let's move it to the next slide. Docker images and containers. Okay. So this is a very important thing you need to know. So what is Docker image? You can see that Docker image is a read-only template containing instruction of creating a Docker container. Okay. So let's suppose you have a Java application, you have a Node application, or you have a Python application. It can be anything, right? So the instructions for creating those containers are called images. They are the instruction. You can think of it as in uh, configuration file. Inside a configuration file, there are instructions. So it's working as a blueprint. Before building before building your home, you need a blueprint, right? So it's that your container image is that blueprint. And your what is your container? Container is that image. When your image is running at the production, at a runtime, your Docker images called are containers. Okay. So Docker images are the instructions, and when the Docker images in runtime, running instance is called as Docker container. Okay. So at the runtime, it's called container, and when it's available inside a read-only template or read-only configuration file, it's called as a Docker image. Before going into the architecture, I would like to tell you how you can create your own container. I guess it will be very helpful for you guys if I tell you how you can create your own image. So this is the application, and this is the basic Node.js application. I have used Express.js. What it is doing? It is actually running a server on port 3000. Okay, this is the port name 3000 port. On port 3000, it is running this application. And if you go into that route, this slash route, it will show you. It will go get. It will send the response. Hello world. Okay. So now what? Now you need to create your Docker image. How will you do that? I have already told you that it is a read-only template, right? Docker image is a read-only template. So how will you do that? So you need to create a Docker file. This is how you can create your Docker file. Okay. In this Docker file, you have to write how you are going to create your container. You can see that there are multiple lines. All of these lines are actually all of these lines are working as a layer in Docker. Okay, and every layer is cached inside your Docker containers. I will be going into all of these details. Don't worry if you are worried what is happening right now. What is happening here? So, so the first line. What is the first line is doing? It is actually this is the first line. What is actually doing? It is actually downloading the Node.js runtime. Before running the Node.js application, you need a Node runtime, right? Let's suppose you are using Java application. You need JVM, right? Let's suppose you are downloading Python. You need that Python environment, right? So this is what it is doing. You can also install a Ubuntu image here, and you can download the Node application and like this, right? What you have to do. Uh, Instead of writing Node, you can write Ubuntu, you can write CentOS if you want to create your own application. Okay. So I have also if you can take if you go back to my words previously, I have told you Docker is a way of standardizing your application, right? Let's suppose me and my two teammates are working on a project, and let's suppose I am working on an application which is running on Node 18, and my teammate is running his application on Node 20. So what they will do? They have to just change this line. They won't have to change everything, right? They won't have to change all of these details, all of these application, like how they are going to solve it. They don't have to do that. They just have what they have to do. They have to just change this version name inside here. Like if someone is using 20, they will be writing 20 inside this line. So first, this first line is doing what is it's doing. It's doing is that it's running the runtime. And second line, work directory, it is actually specifying what is the work directory. So after this line, every command will run on that specific directory. So all of this copy, run, copy, expose, and CMD, all of this command will run inside that app directory. Okay, and the third line, you have to copy your dependencies. So what I'm doing, I'm just moving my package.json. What is package.json? Package.json actually holds your informations about dependencies, right? Like right now I am using Express. Express is a dependency. Express is a package I'm using. So I have to move this on my container, right? So what I'm doing, I am moving it to my place to that container. So this first argument will be passed on your host machine. So it is inside the root directory. So that's why I have mentioned it package star.json. And what is star.json? Star is actually working as a wildcard character. What is wildcard character? On there on In this star, it can be any character. Okay. So it is specifying that if you have package.json, if you have package.log.json, both of the files will be moved to your container. So this is the use of this line. And after this, you have to download your dependencies. All you guys know what after downloading dependencies, what we will do? We have to install the dependencies, and then we will copy the rest of the application from one application to another. And after this, we are exposing the port. So I have already told you one thing, that networks are isolated. In your container, your network is isolated from each other, right? So you need to specify the port number. I have already told you in that in our index.js application, our application is running on port 3000. So you need to open that port, right? If you are not opening that port, how you are going to communicate with our container? That's why you need to expose the port 3000, and then you have to run your application. How we are able to do that? By using the command node index.js, and we have to write cmd. Okay. So what is cmd command? Cmd command is actually uh, used for inside cmd. The things that you will write inside cmd, it will be run after your image has been created and it is running as in container. When your application will run, this cmd command will start. Okay. So this is the difference between run and cmd. It may look similar, but we use run at the time of creating images, but not at the time of running our images. At the time of running our images, we have to use cmd command. Okay. So this is the difference between run and cmd. If you have doubts with any of these lines, you can ask inside chat. Okay, so in live deployment, how will the ports be managed? Like what you are trying to convey, like you are trying to convey that you are running the same port number for multiple applications. I am not actually getting your point. If you guys have any difficulties to understand with Docker file, all of this command with Docker file, you can ask me right now in the chat section. And I will be explaining you how you can open your code at the time of deployment. Uh, okay, so I will give you that time for asking that query. And meanwhile, I am going to run this as in Docker image. So we have our application, and now we have to create our image. So how we can create our image? we have to okay, so first thing you need, that you need a Docker engine, right? So you can download Docker desktop, or you can download if you are using Linux. In Linux it's also available, but you can also Docker engine separately without using the GUI application. So what you need to do, you need to open this application, or open this software Docker desktop, and then you have to run this command. You have to build your image. So what is the command of building this image? Docker build, and then you have to tag it with the T flag, and you have to name this image. I will be naming our container with node application, and you have to specify the directory. And on which directory I'm running our application? On JS directory, right? You can see that in JS directory, we can run our application. We have our application, so we have to put this. Okay, so you can see that our image is created. So you can see that our image is successfully finished building. If you want to see if your image is successfully created or not, you have to check it with Docker images command. If you write Docker images, it will give you all of the details about images. Okay, so this is your application node app. Also, one thing you can see that this is saying that these layers are cached, right? So why it is showing as cached? I have already told you one thing, that every line, right? This line, the line number 2, line number 5, line number 8, all of these lines are working as in Docker layers. Okay. And every layer is cached from one and another. Okay. So at the time of when you are building the same application again and again, it won't be doing the same thing again and again. It will use the pre-built cache and use it. So why it is showing that cached? Because I have built it image before coming into this session. I have built this image at the time for testing, right? So that's why it's showing as cached, because it's already cached in Docker. In Docker, all of these layers are cached. That's why it's showing every layer, all of these layers cached, and the process is going faster. So if I change this line, like I'm writing a console log for your okay. So I'm writing again another hello world. Okay. So if I build our image again with the same tag, you can see that layer 2, 3, and 4, all of three layers are cached, but our 5 layer is not cached. Why it is happening? Because we have made changes in our files, right? In the fifth layer, what we are doing at the fifth layer, this is the fifth layer, right? Copy command. This copy, we are copying the rest of the application from one place to our from our host to our container, right? So we have made changes into our index.js. That's why it's not using the pre-built cache. It's copying the whole thing again. That's why this layer 5 is not cached. Okay. So this is the thing Docker is using for faster execution. At the time of production or deployment, it will help you out with faster execution. I guess you don't have any difficulties with that. Let's run our. So we have successfully created our images, and if you want to see your image, you can go into your Docker desktop, and inside the images, you can see our Node application is running. This is our Node application, which is created 1 minute ago, and now you have to run this as a container, right? So what you have to do, you have to use Docker run, and then you have to put ITD flag. IT means interactive mode. In an interactive mode, we will be running our container, and D means detached. By the time our container is created, we will be detached to that shell. Okay, and then we need to specify the port. One person was asking inside the doubts how we will manage the ports, right? So this is how we are going to manage our port. we have to specify our port, right? Like we are using 3000 port, right? First, we need to specify the port number on our host machine. So this will be running in our host machine 3000, and we need to map it to our container. Okay. So why we are writing this two times? First time it is first time it is denoting that first one is used for host and second one is used for container inside container. Okay, so let's suppose you have three different applications. Okay, and the three of these applications running on the same port. Okay, same port, let's say 3000. So how will you able to run that? You have to change this port number on the host side. If you can change it to the 3001, 3002, or 3003, it won't be affecting your other ports. Okay. So we know that we can only occupy one port for one task, right? We cannot use one port for multiple tasks, right? That's how we are going to do this. If we have multiple ports, we if we have multiple containers on the same port, we have to change it on the host machine. So I am going to run our 3000 port on the host machine to our container machine, and then we need to name our then we need to specify the name of our image. This is specified, and now we can run our. So you can see that our application is running. If we go to our Docker container, you can see that this is our container. It's running. And if you go to that containers terminal, you can see that hello world, right? This is the hello world. You can see that this is the console log hello world, and this server is listening on port three, localhost 3000. So if we go to our localhost 3000, you can see that hello world. So our app is running perfectly. Congrats! You know how you can create your how you can run your application using Docker. This is a very simple task. You won't need to worry about anything. Now, if you have any doubts with all of the things that I have did, you can ask it on chat section. Okay, so one doubt I have that what about security measures in Docker images? Okay, so there are tools like Docker Scout, and there are multiple ways to measure the securities. Docker Scout is a very good way to how you can monitor the dependencies. Like if your container is actually breaking at the time of production, if your app image is vulnerable to security purposes, right? So Docker Scout, this command will help you out to check that vulnerabilities. Okay, so maybe you can check out my YouTube channel for this security, how you can perform security measure using Docker Scout or other tools. It's actually a vast topic. I cannot explain the whole topic in this session. I can tell you on that next previous session. Up to this point, do you have any doubt? You can ask it. How can you effectively manage persistent storage in Docker when you are scaling application across multiple servers or hosts? Okay, so this is another thing. This is not actually tied with containers or images. I will explain you on this other time. There is a thing called Docker volumes and Docker images. Docker volumes, right? Docker volume will help you out with persistent storage. Everything that you are building in Docker file, it's not actually persistent. Okay. When you are stopping your application, everything that is inside that application will be also deleted. Okay. So there is a so how will you leverage the power of persistent storage? There comes Docker volumes. Docker volumes will help you out with the storage solution. Okay. So before going into that, I would like to ask you a question. You can see that I have used this command. copy package.json, and then I am again using this command, copy the rest of the application from my host machine to container. So I have used these two lines, right? So this can be solved using one line easily, very easily. Why I am doing it like in this way? Why I am not writing this as in copy the rest of the application from the other? Like I have written it in a way like I can run this command after this line. Wait, huh. And then I can remove this line. I can. This is also a perfect solution. This won't cause you any trouble. So why I am doing it in a way? Why I am using this specific technique? Can you tell me that? This is also a quiz. If you know this, you can write it inside a chat box. Okay, so the first, so what do we not copy the node modules folder? Okay, actually we are actually you can see that we are copying our node modules from our Docker to from our host machine to our container. You can see that like we are moving our. I have written it down that we are copying the whole application from our host machine to our container, right? If you go to our container, you can see that inside your files in the app directory, we are running everything inside our app directory, right? You can see that our this is our node modules. This is also moving from our host to our container, but we shouldn't be doing that. What we have to do is, if you want to ignore this, what you have to do is you have to create a Docker ignore file, and there you can specify the files that you don't want to include. You can see that node modules. Node, I don't want to include my node modules inside my container, right? Node modules will be automatically downloaded, right? When I am running that node npm install command, it will be automatically downloaded into my container. So why will I increase the Docker image size, right? You can see that our Docker image size is very heavy. If we move our node module, host to node module to that other our container, it is not a good way to do that. So that's why we need to put our node modules inside our Docker ignore. Docker ignore is same as git ignore. What is git ignore? Inside git ignore, you have to specify all of those files that you don't want to include it in your GitHub repository, right? So this is same as in Docker. You don't want to include your node modules in your container. So what you have to do, you have to create a docker ignore file, and inside that file you have to mention the folder name, and it won't be included into your container. Okay, but my question was why I am doing this line in a certain way. Why I am like this line. If I am doing this in a certain way, you can see that this is also a very good way. Okay, this won't cause you any trouble. If I run this application, if I build this again, see everything is changed. But if this is not occurring any issue. But in previously I have written it in a specific way. Why I did that? This is a quiz. If anyone can explain why I did this in a certain way, they will get stickers. Okay, so first, I'm also solving a doubt. We can use Docker ignore file and mention the files folder which do not need to be copied because it will be installed. Right. Orpon is also right. List down the Orpon names. He's also making our session interactive. Somebody, did you listed down his name? Orpon? Yeah, good.
Yeah.
Will force unnecessary reinstallation of dependencies. This is also right. This is also right. Diptonil is also right. It will for unnecessary reinstall dependencies. It is also good. Okay, so Onkunpal, what is Onkunpal is saying? When we change something in app, we need to reinstall dependencies. We can leverage the usage of Docker cache to speed our build. This is the exactly our perfect answer. Very good, Ankun. I guess he knows Docker very well from this line. So why we are doing it in a certain way? If I can go back to my previous Docker image command, you can see that first we are copying our package.json and package.log.json and moving it to our container. Then we are downloading all of the dependencies. Then we are application code is, or then the rest of the application's code will be moved to our container, right? So let's suppose you are working on a production environment, and let's say you have made changes in your application. If you have made changes in your application, so that package.json, this if you have just installed this dependencies, it will be let's suppose you have made changes in your application, okay, and you have not downloaded any dependencies and you have not downloaded any packages. So what your Docker will do? First, Docker will check up to which layer it is not cached, and then after this layer, it will rerun this re-execute this layer again. So this is very unnecessary thing to do, right? You don't need to download your dependencies again and again. If anyone is changing anything inside your code, you don't need to download your dependencies. Like if you go to my last build, you can check up to layer 2. What is layer 2? Layer 2 is up to work directory, right? Up to work directory, it is cached. But after this, the copy command is running, then the downloading dependencies is running. But I haven't made changes inside my dependencies, right? So this is a very hectic task. Like we all know that downloading dependencies takes a lot of time. So why we are going to why we need to do this very frequently? We won't be downloading our dependencies very frequently, right? That's why we do this in a certain way so we can optimize our build time. When you will be working in a production environment, you really need to know how you can reduce your build time, right? This is a very important task. At the time of you want when you will be doing your first job, let's suppose you are working for a company, you won't be writing code all day. You have to also work for optimizations, right? This is what it does. So that's how this is a technique. This is used to reduce the build time of your application image. So what it is doing? It's first checking if your package.json has any changes or not. If your package.json is has any changes, then it will download these dependencies again, and then it will copy your whole directory one to another, and then it will run this. But if you haven't downloaded any dependencies, it will be cached up to this layer, up to layer 3, up to layer 4. Up to layer 4, everything will be cached. And after this layer 5, it will run this command again. First, it will call, then after this, it will copy our rest of the application from our host to container. Then it will expose and then it will run our application. So this is the reason why we write this in a way. If it is irrespective of any other solutions. Let's suppose you have Python application. You need to pip install, right? So in the Python application, first you need to move your requirements.txt into your in this application, like in this copy layer. First you need to move your requirements.txt from your host machine to your container, and then you have to run your um, download your dependencies using pip install. In Python, we don't use npm install. We use pip install. And what is this production flag is doing? Production flag is actually helping you out with freezing all the dependencies. It will also help you out at the managing your dependency graph. I am not going into the details of it, but at the time of building things, you need that flag. Okay, so this is a very necessary flag. At the for Python, I guess it's frozen log dependency, something like that. I don't know. You can search it on Google. You may find it. And then we are copying the whole rest of the application from one to another. Okay, I guess up to this point everything is clear. You can see that in the files we can see in this app directory. If you go to the file section, you can see what are the file folder structure of our container. Inside app directory, we are doing our whole operation. Inside app directory, you can see our index.js node modules. You can find everything. And if you want to run the commands, let's say you want to run who am I. So you are checking like you are get the username. Right now you are using the root username, root user. That's why it's showing root user. Also, I would like to tell you for the security purposes, you won't be deploying your application with the root user privileges. You have to always change the user privileges to a non-root user. Like you can use node user or any user, and then you have to run your application on that. Okay. So there is a thing named as an user group. In this user group, uh, you can specify on which user group you are going to run that. Up to this point, do you guys have any issues understanding all of these layers, caching, Docker? Where does Docker Scout checks vulnerabilities? The Docker Scout is a normal command. It is provided. You can see that like this is the command. Docker Scout quick review. By using that command, you can check your what are the vulnerabilities of your application. You can also check it using Docker Desktop. Let me check. Yes. So in that Docker Scout, if you want to check this vulnerabilities, what you have to do. Hmm. So right now I don't have any vulnerabilities. That's why it's showing zero vulnerabilities. If you have vulnerabilities, it will be shown inside this, right? You can also run Docker Scout command in your inside your terminal. You can also check it out on your Docker GUI application. If you have vulnerabilities in your application, it will be shown inside here. Okay. Any other doubts other than this? I guess no one has any doubts, so we can move further. Okay, so now I am moving it to the production based scenarios. Okay, so in production, you won't be using JavaScript application. You will be using TypeScript, React, or any kind of application. You will be running your React application in TypeScript, right? So at the time of TypeScript, what you are going to do for you won't be running your application in one instance, right? First, you need to build your application. Then your JavaScript code will be converted into your TypeScript. First, your TypeScript code will be converted into your JavaScript code. Then it will be run, right? So that's why we need to use multi-stage building at the time of production use cases. Multi-stage building. So, do you guys have any ideas what is a multi-stage building? This is also a quiz question. You can tell me what is Docker multi-stage building. Like you can tell me what is Docker multi-stage building in one sentence. It will be fine. You don't have to go into brief. Just one line answer. You can also answer it in a one word. I'm waiting, guys. I'm waiting for your answers. Don't write too much. Just write it in a we can specify multi-stage building, how we can build a project to be production ready, then we can run as an image. Uh, Usage of no, it is not actually right. There is a reason why we use multi-stage building. Okay, how do I install Docker? You can install Docker using going into this Docker. If you want to download Docker, you can go into that Docker desktop. If you think why I have laughed on this chat or no Chatterjee's chat, because he knows everything. He's actually mocking me, I guess. By okay, great. Okay, so Docker multi-stage build use multiple statements to create optimized images by copying only necessary artifacts to final stage. Right, perfect. Deeptanil is correct. Onkon Paul, we can use different bases, one for building the application, one for running. Right. Great. Better organization. No, it is not actually used for organization. It is actually for optimizing the application. Okay. Please list down all of these names. Docker Scout checks for vulnerabilities in container images by analyzing the software packages dependencies used in those images. Right. This is actually for Docker Scout. I have asked for Docker's multi-stage building. Okay, so let me explain what is a Docker multi-stage building. First, I have to explain you what is a TypeScript application. At the time of building your TypeScript application, you have to create your dist folder. So what will be inside your dist folder? In your dist folder, you have your all your transpiled JavaScript commands, right? What is TypeScript? TypeScript is actually a superset of JavaScript. Everything that you will run inside TypeScript, it will be converted into a JavaScript code. So so you don't need the whole application, right? You don't need the TypeScript commands. You just need that build folder, right? So you are just wasting the container size by taking up all the spaces of TypeScript code. You don't need TypeScript code in your final stage, right? So that's why we need to use multi-stage building. So this is my TypeScript application. Inside this source, you can see that this is the same application. I am I have written it down with using TypeScript. So you don't need this TypeScript file, right? This TypeScript file will be converted into a JavaScript file, and you need only the JavaScript file. So how we are going to do that? Let's focus on this. So we are doing the same thing. First, we are using this from command. Then we are specifying the same thing as in node runtime, and then we have to alias it. This is a alias. We are naming this layer as in build layer. Okay. Then we need to specify the work directory. Then we are moving our package.json and package.log.json to our application. Then we need to download the dependency. Then we are copying the rest of the application from one to another. Then at this layer we are not if you go to our JavaScript, you can see that we are exposing this and then we are running it. So this is done, right? But inside TypeScript application, first we have to build it. So what we need to do, we need to use this command npm run build. What this npm run build is doing, this npm run build is actually using this npm tsc command. It will generate all your JavaScript code. Okay. After this, if you go to that, we have moved to our another stage. You can see that we are using again another from, right? So another from means another stage. Another stage means another a totally isolated environment, right? This is our separated stage. This from is not happening in the same stage, right? This is one stage, and after this 20 line command, this is a separated stage. So in the separated stage, we are again specifying, we have to specify our work directory. We have to move our dependencies again. Then we will be downloading our dependencies again. But instead of copying the whole application, what we are doing, we are using from build. What from build means? From build means from build stage. This is the stage, right? This is one stage. This is stage one, right? From build stage, we are moving this dist file. When you will run this npm run build command, it will create a dist folder, and inside that dist folder you have all of your javascript codes, right? All of your javascript codes, you only need that, right? You don't need all of this TypeScript code and all of this, right? You need only JavaScript code. So only this will be uh, moved into your container. That's why we have written it out. We are just moving this folder. We are not application. We are not actually moving the whole application. We are just moving this. So what this line is doing? From build stage, give me that dist folder and move it here. From this stage, move it here, and then we have to expose our application. And then how we can run our application? We inside the dist folder we have our index.js file, and we can run it using Node. So now if you want to build that image again, you can use docker build hyphen t. What is hyphen t? This is Node. We have to name tag our image, and then this will be Node TS application. I am naming it as an TA TypeScript application, and inside TS folder we have our TypeScript application. We are running all of this command. You can see that up to build command everything is cached, right? I have told you in Docker everything is cached. Why it is cached? Because I have already pre-built all of these things previously. That's why it's cached. And then it's using this build. From build, it is using package downloading package.json. Then it's downloading all the dependencies. Then it's using the stage one, and from stage one, it's moving this folder from our host to from our stage one to our stage two. Okay. Now what we have to do? We have to run our image as in container. We all know images, Docker images in runtime called containers. So what we have to do? We will be running the same thing. Now I am also going to solve that another doubt. How you are going to separate your ports, right? Like if you go to my TypeScript application, this is also running on port 3000. I haven't have any dot environment. I don't have any environment variables, so it will take 3000 port, right? So what I will be doing, I need to specify it as in 3001, cause 3000 port in our host machine is already occupied with our JavaScript application. We cannot run that JavaScript application on the same port. We need to specify it using our 3001 port. So what it will do, it will map our 3001 port to our 3000 port. And at the time of node application, we need to specify our the image name of our TypeScript application. So we can check that using our Docker desktop. Inside images, this is the name of our image, Node TS app for our TypeScript application. You can see that our TypeScript application is running. If you go into our container, this is the Node TS application. So one is running on 3000 port. Both of these applications are running on 3000 port. But when it's coming into our host layer, like host, what is this host? Host is my local PC, right? In my local PC, if I go into that 3001 port, it will be redirected into my TypeScript application. If I go into that 3000 port, it will be redirected into my JavaScript application. So if I run localhost 3001, we can run our TypeScript application. You can see that on 3001 port, we are running our TypeScript application, and on 3000 port, if I refresh it, again we are getting this hello world. So this is our JavaScript application, and this is my TypeScript application. And not surprisingly, we are using the same ports, but not as in the host layer. It is actually separated. That's why I have told you previously, Docker isolated one container from one to another, right? That's how Docker isolated one container from each other. Okay, this is the level of isolation. You can see one application won't break another application. Everything is isolated from each other. And also, I need to show you one thing. If you go into our TS application, hmm, if you go into that file, inside our app directory, all of our folders have there. See, you cannot see our source file, right? Right now, in our TypeScript application, we have our source application. Inside source, we have index.txt. But when I go into my container, I am not able to see my source folder. I can only see my disk folder, right? Inside this folder, I have my JavaScript application. What is this index.js? Index.js is that all of these types JavaScript code that are transpiled by or by using all of this TypeScript code. It is transpiled into JavaScript code. That's why we are only we need only that JavaScript file. We don't need all of these TypeScript files, right? So that's how we are reducing this image size at the time of when let's suppose you are copying your image from one person, you are sharing your image to one person to another. Let's suppose you are downloading your image. This will help you to fasten your execution. Also, it will reduce your image size. If you go into that image size, Node TS application. It's also taking, very surprisingly, Node application and TypeScript application, very surprisingly taking the same space. Why it is taking the same space? Because we are using multi-stage building. Our JavaScript application, our JavaScript application only has JavaScript code, but our TypeScript application has TypeScript code along with JavaScript code, but we are not using those TypeScript code. That's why it is helping us out with the same storage size. That's how you can leverage the power of multi-stage using. Okay, let's time for another quiz. This will be the last quiz for today. If I go into my files section inside my container, I have already explained you why I have only dist folder. So what is the purpose of this dist folder? I have already told you what is the why it is showing this in a way, why it is generating this dist file, what is the purpose of this folder. You can write it down on the chat board. Okay, so one doubt we have, can each layer be changed and cached individually for modification to bundle all of the JS files code? Okay, I'm coming into that doubt, but let me first check this quiz answers. To bundle all the JS files into a single file, right? Bhalu is right. Ongoing disk folder contains transpile TS code into JS. Nice. Can we use multi-stage function? Okay, so Bhalu is right. Bhalu, give stickers to Bhalu, I guess. Okay, so can we use this multi-stage functionality in Docker Compose file? Docker Compose is actually used for managing your multiple containers. Okay, it is not, multi-stage building is used at the time of building your application. Okay, when you are building your application, you will be using that multi-stage building, right? How will you leverage the power of multi-stage building at the time of composing? Docker Compose is a Docker, inside Docker Compose file. You are going to manage how you can write all of these commands, how you are going to manage and run all of these containers, right? It is a file that stores all of the information how you are going to manage and run all of these containers. It is not actually used for building. So at the time of building, we need multi-stage functionality. So this is for reduce building. This is for reducing build stage image size container. Can each layer be changed and cached individually for modification? Yes, you don't have to do anything for that. Docker is automated with that. Docker engine is actually caching, or Docker engine is cached all of these layers. So you don't need to worry about anything. What you need to be worried about is that you need to focus on your Docker file. Inside your Docker file, you are going to specify your image creation instructions, right? At the time of putting down your image creating instructions, um, you need to specify it in a way so you can modify your how things will be cached, how things won't be cached. Okay, so in summary, the dist folder in the container is used to hold the build compiled code in your application needs to run, providing them clean and efficient runtime environment. Right answer. Devojyoti, distribution folder. No, it's actually not a right answer. It's not. It's actually used to your when your TypeScript code will be transpiled into a JavaScript code, right? What is your TypeScript code? That's in at the end of the day, your TypeScript code is just JavaScript code with extra functionalities. So your TypeScript compiler or a I can say transpiler. Transpiler will be a great word for TypeScript. TypeScript code will be transpiled into all of the JavaScript code, and inside the dist folder, you have all of your JavaScript code. So this is the purpose of having this dist folder. Allow you to run the test within containers, which can help to ensure that applications are running as expected. No, it is not the expected answer, desired answer. To pack the production ready distribution files for running the Docker. No, it is not right. One, reduce Docker image size. Two, production ready files. Yes, this is the right answer, Devojyoti. This can be used as in reduce for reducing Docker image size or production size, but we are not actually reducing this Docker image size when we are specifying it on inside our Docker file. It is helping us out with reducing this Docker image size. Okay. TypeScript as typing functionality is normal JS code. Right. Totally right answer. Okay. So we can move to our next slide. So next, now we will be focusing on our architecture. So right now we have run our all of these things like how you can run your application, how you can rebuild your image, how you can run your image, how you can run your image like a container. We all did all of these things, but what is happening behind the scenes? This is the architecture behind all of this. All of this is happening. So first we have a Docker client. What is a Docker client? Docker client can be anything. Docker client can be your CLI, like in the terminal. In the terminal, I am using this Docker build command, anything, right? So this is my CLI. This is working as a client. Your GUI application can be a client. You can run your application inside your Docker desktop. Okay. So all of this command, you can run all of this command using this Docker client. Docker client helps you out with making requests to your Docker daemon. What is Docker daemon? Docker daemon actually checks if you have those images inside your in your PC or not. If you have those images, then it will help you to run those images as in containers. You can see inside this image. First we are building this image. After building this image, we need to pull this image. Then Docker daemon will check if you have this image inside your Docker host or not. If you have this inside your Docker host, then it's fine. But if it is not present inside your Docker host, it will pull this Docker image from the Docker registry. I have already explained you what is Docker registry. You can think of it like as in GitHub. Okay, but For containers, GitHubs are registry. Like repository, they have registries. There are multiple types of repositories, privates and the public ones. I have also told you what are privates and what are the public registries. So what Docker host will do, first Docker daemon will check if the image is present inside your host machine or not. If it's not present in your host, then it will check in your registry. Then inside your registry, it will check if it is inside your public or the private registry. After this, if it finds your image, it will pull that image out and then it will run it as in container. Okay. So this is not that very complicated. You can see that Docker host is actually that middleware or that main execution process which is helping you out to making those requests. And who is sending all of those requests? Your Docker client. Your Docker client can be your CLI, your Docker desktop. So this is all about Docker. Do you have any difficulties up to this point? Like understanding this Docker architecture? If you have anything, if you are not clear with anything like Docker architecture, you can ask on chat. Does Docker push and pull can work for private applications? Yes, it will also push and pull for Docker private application. At the time of private, you need some kind of encryption, right? When the Docker registry have private registries, they will use encryption like they will use public key and the private key with the leveraging the power of public keys and private key. They will encrypt and decrypt so you can use the private you can pull the images from your private registries. Any other doubts? Inside your Docker hub, you can see your registries. If I go into that container, Docker hub. Okay, let me check this out. Where is my Docker hub? Is okay. I'm just going into internet. So this is where you can find all of these registries. Docker hub. Hmm. I need to also sign in. Hmm. So these are the all of these images that I have pushed into my public repository registries actually. You can all of these registries are public. You can see that public registries. So you can use this in your application. What you need to do, you need to pull this image from this image name. By using this image name, you can use my image into your PC and you can run this image as in container inside your PC. So it's a very so I have already told you how you can share how you are going to able to share your images with your coworkers. That's how you are going to do it. First, you are going to push it to the public or private registry. Then your coworkers will pull it from the private or public registry. That's how you are going to share your images among or across teams. There are some queries from the Google form. Okay, good. How does high-end OS installation like Windows and Mac is shortened to such small Docker image? Okay, so there are multiple types of images. Like for simpler Linux distributions, we use Alpine images. Alpine Linux distro is very lightweight. That's why we use this is a very shorter size images. That's why for Linux images we use Alpine mostly for Docker image running. How for we don't usually use Windows or Mac for Docker. You can use Windows or Mac if you go into that Windows images public Docker hub. You can see that yes. Hmm. So this is provided by Windows. They are actually if you go into the Docker Hub, these are actually pushed by Windows. They have they have these are the tags. These are the image tags of their image application. If you want to run um, Windows images, you can go check out their registry, and then you can pull it to your own host machine, and then you can run it as a container. How can Docker be integrated with CI/CD pipelines for automated deployments? It's very simple. So at the time of CI/CD implementation, first you need to download this Docker environment, right? Your CI/CD in your CI/CD pipeline, first you need to download that Docker inside your CI/CD environment, right? Let's suppose you are using Jenkins. Inside Jenkins, you need to first download the dependencies for Docker. Then you will be able to run those images and containers inside that Jenkins, and then you can run and execute all of these processes. All you can then you can leverage all of these pipelines. You can automate your deployments. These are very good questions. I would really like to. Soon I will be posting a video in my YouTube channel. Go check out my YouTube channel. Soon I will be posting a video on how you can push your Docker images using CI in CI/CD pipelines. I want to know more about JSON. JSON is not actually tied with our session today, but JSON is actually JavaScript object notation. It is used for data serialization. When you are sending one file from one person to another, you cannot send it as in uh, a whole text file, right? Let's suppose you are communicating with your web application, right? In When you are communicating with your web application, you cannot be sending your docx file or word file or your ppt file with your web server, right? So you need a simpler and more reliable way to communicate with your web server. So that's the part JSON comes in. And JSON will help you out with serialization and deserialization. First you have need to specify what are the things you need. If you are communicating with your web server, let's suppose you are logging in, right? So you need to specify email and password. You need to pass it to your web server, right? Already you have looked at it like in when I was signing in into my Docker Hub. First, I was putting my details, email and password, right? Then what this user interface will do? This user interface will convert all of this information into a JSON format, serialize it into a JSON format, and then it will um, communicate with that web server, and then web server will check, okay, so this is my email ID, so this is my password, and then it will send the response, and then it will help me out with my signing on login logic, anything. What is Kubernetes? How it is related to Docker? It is a very good question. So Kubernetes is a orchestration tool. What is the orchestration tool? Uh, you have already seen that right now we are running our Docker application, right? So there are multiple things that we are not actually tying it, right? We need to manage our security. We need to specify like the vertical scaling. We need to specify our horizontal scaling, right? For large scale project, you need your vertical scaling, horizontal scaling, all of this scaling. You need to scale your application, and you cannot do that very easily with Docker. Docker has its own orchestration tool. It is called as in Docker Swarm. But for large application, we don't use Docker. It is good for personal projects, but at the time of production, we use Kubernetes. What Kubernetes is doing, it is used to allocate memory to your container. First, it will allocate memory to your container. Then it will help you out with that scaling thing. Then it will help you out with that load balancing thing. What is load balancing? When you distribute the traffic among your servers. One server is not enough this request. Let's suppose right now you are having one request per second, but after some time when you are going to deploy your application to the production, you may be experiencing thousands of millions of requests per second, right? At the time you will need load balancing. You need multiples of servers to handle these loads. So how you are going to do that using load balancer? And Kubernetes has that capabilities to manage container goes down, it will restart your container. If you are going to load balance, if you are going to need load balancing, Kubernetes will do that. If you need to specify security, Kubernetes also has very there are multiple types of extensions and there are multiple types of way inside Kubernetes, so you can do multiple kind of things. Also, you can okay. So this is Kubernetes. At in one sentence, Kubernetes is an orchestration tool for containers. Nice answer. Kubernetes orchestrate large-scale project. It can also help with auto heal if server goes down. Yes, it is a very good point. Like if your server goes down, you have to restart it. Right now you have to restart it first. So you are going to experience some downtime. In production scenario, you downtime is not expected, right? So to reduce downtime, you need a orchestration tool. So Kubernetes will automate that task for you. They will monitor and all of these things. They will do the monitor. They will store the logs. They will help you out with the storage. Kubernetes will do the rest of the things for you. You need to specify the configurations in a way. What is load balancing? I have already explained you what is load balancing. Load balancing is used when when one server is not enough to handle this load. You are going to need you are going to distribute your traffic into multiple servers, right? Let's suppose you are allocated with one task, and you are not capable to do that. Maybe that task is not doing for one person, so you need your with you, right? That is what the load balancing is. You need all of the multiple servers along with you so they can handle and distribute the traffic. Yes, Google made it for their box system used for highly complex high traffic system. Yes, Kubernetes now it's actually not under Google. When it was under Google, it was named as in Borg. They are right now, but now Kubernetes team has shifted from Google. Also, there are multiple types of load balancing like round robin, least connections. I'm not going into the details of how you are going to load balance all of these traffics, but this is the main reason behind how you are going to load balancing. Kubernetes will also help you out with that load balancing. Any other doubts? Okay, I guess we are finished with our doubts. Oh, I have already told you what are the Docker volumes are. Docker volumes help you with persistent. Like if you need to share your data, like Docker containers are very ephemeral. What is ephemeral? Ephemeral is a state where you after your application or your container stops, it won't persist anything. Okay. So even if you have multiple things are running your database, okay, and your container stops and then you are restarting it, nothing will be stored inside that container. This is the scenario when you are going to need Docker volumes. What Docker volume is? Docker volume will help you out with that the data persistent, also with the data sharing and data backup. So if you need data backups, Docker volume will help you out. If you need to share one host to another, if you are going to share all of this multiple containers, Docker volume will also help you out with this. Docker networking is a very vast scenario. Like how Docker is going to communicate with each other. Like what are the ways for containers? So one container can be connected with other containers. I have already told you inside Docker everything is isolated. Okay. So we need some kind of way so every container can be together. So there are three ways I have mentioned it. Bridge network. So containers on the same bridge network can communicate with each other. So within the same bridge, containers can communicate with each other. Host network is used when you are not isolating your container network to your host network. Okay. So I have told you previously that Docker at the time of running your container isolates your network environment too, right? So when you are going to use host network, it will remove that isolation so people can have direct access to your container from your host machine. And none network is when we use none network, we are actually specifying that we are not going to communicate. This container is not going to need to communicate with another container. Okay, so we need isolated security purposes. We use none network. By default, Docker maps every container with bridge network. Default bridge network is used for networking. And after this, we have deploying and managing your Docker containers. I have already told you how you are going to deploy. You are going to deploy your Docker containers with using Kubernetes. There are also you can also deploy your Docker in your virtual machine, like in any EC2. Docker is very flexible. That's the beauty of Docker. You can deploy Docker to anywhere. Like you can deploy Docker into a virtual machine. You can use inside a serverless platform. You can also deploy it on the Kubernetes. So I will also suggest you first don't rush it into Kubernetes. First simple solutions like first deploy your containers into EC2 instances or your serverless instances, then move it to the Docker, then move it to the Kubernetes. Okay. You have also Fargate like solutions, like all of these cloud have solutions for own. They have their own orchestration tool, like AWS have Fargate. They also have EKS, Elastic Kubernetes services. And container management, I have already told you, container management orchestration tool is also help us with container management. And for orchestration, I have already told you what is Docker Swarm. Docker Swarm is same as Kubernetes, but it is used for small scale project. Let's suppose you are running, you want to orchestrate your container in your host application, right? So at that time, you need Docker Swarm. You won't be needing complex Kubernetes. One will be a great thing for you at that scenario. So this is all about Docker. I guess I have explained it. If you have any doubts, you can ask me. How long is going to continue? Sorry, but my data will be over. Yeah, we are done with our session. It's done. It's done. If you want to know more about Docker orchestration, DevOps, go check out my channel. You will find all of these things inside my YouTube channel. I hope this explanation helped all of you guys. Thanks for joining this session. If you have any doubts, you can ask me. I guess we can. Do we have any doubt? Thank you, sir. Alright. Thank you. Thank you. Can you give the link of your YouTube channel again? Yeah, sure. I am sending it into the chat. Uh, I have just started this channel, so it won't have many views, but you can follow if you like my explanation. You can follow my YouTube channel. This is my YouTube channel. You can follow. Great to know, Moyuk. If any of my video help you out, I will be really glad. Anything? Where is the attendance link? attendance link. Hello, Somanjit. Hello.
Hello. Okay, so
Someone is
thank you.
asking.
Yeah, yeah, I have
Okay.
shared the form link.
Okay. Okay. Good. Good. Great. Great.
Okay. So now I'd like to conclude the session. So thank you so much, Ishita, for this wonderful session. We have truly understood a lot today and learned a lot today. So thank you so much for teaching us about Docker and containerization. And I hope you guys liked it. If you have any more queries, the Google form link is still up. So you can just post it there and we can just convey the query to Ishita and he can like post about it on his YouTube channel. And if you have any more questions about our community or anything else regarding the Resourcio community, we also have a YouTube channel, which is, I think, named Resourcio. Please check it out. And I hope you all had a wonderful day. And that's it. Thank you for attending the session. Good night, everybody.
Thanks, guys, for joining. Okay. So we are going to wrap up our section. Bye bye. Good night. We filled this previously while asking task. Do we need to fill it again? No, no. If your doubt are solved, then you don't need to do it again. It's fine. Okay. So I'm leaving.